Hi, in today's video I'm going to show you how to reverse a UTF-8 encoded string in Blaise. My name is Karol Moroz and you are watching Make Programming Fun Again. So the story begins a few videos ago when I was doing the Kernighan and Ritchie challenge, and the Kernighan and Ritchie challenge was basically my idea to read through the whole Kernighan and Ritchie book and do all the exercises, and I actually stopped this challenge before completion because the second chapter of this book was just too boring for myself and my viewers. But the exercise 119, what I did on stream was such: write a function reverse s but reverses the character string s. Use it to write a program that reverses its input a line at a time. And when I did this exercise on stream, one of the viewers commented that I technically did not do it correctly, because the exercise says to reverse the character string s, and what I did was I allocated a new string and then returned a reverse string. So in today's video I'm going to try and do the exercise correctly. And the first thing we're going to do is we're going to need to allocate a line, and this is going to be a pointer to now, and then we are going to need to define a variable called size t and number of red bytes, and for n red equals getLine, and we're also going to need a variable for the length. So I'm going to pass the pointer to line and the pointer to length, and then we're going to be reading from standard input. As long as this is not -1, we're going to, for now, let's just print the line. And then we need to free the buffer, and and this is a while, not a for. And for now, let's just print it. And you're also going to need some sort of text. So I'm going to use a sample text file this time. And in here, let's just write some English text, another line of English text. Okay, let's see. We make main, we run main, and it's waiting for us, waiting for input. Okay, so we are now printing lines of input, and now let's try reversing these lines. So I'm going to write a function called reverse, and it's going to take a pointer to the char vector s, and in here I need to know the length of its string. So I'm going to use strlen, which comes from string h, and when we say then we define a variable called n, and this is going to be length divided by 2, and for int I equals 0, I is less than n, I++, we're going to need to swap the byte at the beginning of a string with a byte at the end of a string. And I'm going to use a library called std, the header file called stdint, so I can use uint8t, which is an unsigned char. And this char is going to first be s at index of I, and then we can say s at index of I equals s at index of length minus I minus 1. And this index looks a bit complex, but it basically means we want to look at the end, at the ith byte from the end of a string, and actually the last byte of a string is going to have the index length -1. And then you can say s at index of length minus I minus 1 equals the buffered variable. So now let's say reverse line, and then we print the reversed line. I'm going to rebuild this, and this is currently reversing the lines correctly, but it's also including the new line in the output. So I'm just going to say that the length is actually string length minus 1. And this way it is not going to include, or maybe I can just say if s at length minus 1 equals a new line, then length minus minus. Okay, let's see. Yep, so now we have exactly the desired amount of new lines, because we are also not returning, we are not returning we're not swapping the new lines, we are just swapping everything before the new line. So now ignore the do not reverse the new line character if the given line ends with 1. Okay, and this is great. The problem starts when the sample text also contains some extended Latin characters. So for example, the example I would normally use is extended Latin in the form of Polish. So in the Polish we have this sentence that contains all diacritics in the Polish language. And if we try to reverse it now, we're getting gibberish. Let me just show you maybe for those of you who cannot read Polish, I'm just going to show you the original text and the reverse text. So this line is not only shorter, it also contains gibberish. It contains characters that are not used in Polish at all. So obviously this is not ideal. The thing is that this variant of reverse, it only works with ASCII encoded strings. And while ASCII encoded strings are perfectly valid Unicode, if we have anything beyond ASCII, then we need to go deeper. So the one approach to reversing a UTF-8 encoded string that may contain multi-byte characters is to reverse the bytes first and then go back from the end of a string and see if anything was broken. And if there was anything broken, we just reverse the strings again. So I'm going to define a new function that's going to reverse byte sequences of a given length. So let's just call it reverse bytes, and it will be contain the beginning of this string and the length of the segment we want to reverse. So now it's basically going to do exactly the same thing as this. So I'm going to rename this variable to s so we can reuse it here. And now we can just call it here reverse bytes s, and length is length variable, like so. So now if we recompile it and rerun it, we are getting the same incorrect answer. So now what we want to do is I'm going to show you how UTF-8 encoded multibytes actually look. So according to UTF-8, which is the most common UTF Unicode standard, Unicode. What is the official name? It's a Unicode transformation format. So this means that we are taking a Unicode string, which is basically a sequence of Unicode numbers or code points, and we need to convert it to an actual byte string. So what this does is, what UTF-8 does is that if the character in the string is just one character long, which means if it's it's in the ASCII subset, then we just encode it the same way as we would in the ASCII subset. And then if the character has to be encoded in 2 bytes, then the first byte is going to start with 110 in binary, and the second byte is going to start with 10. Then if it's 3 bytes long, then the first byte is going to start with 1110, and the remaining bytes are going to start with 10. And then if it is 4 bytes long, then it's going to start with 11110, and the remaining bytes are also going to start with 10. So this is very easy to imagine in binary, and luckily the specification also includes a few definitions that we can use in like a for loop. So in our reverse function, we start with just reversing the bytes, and then we can do another loop where we say int I equals length -1, because we want to start with the last character that is not a new line, and then we go until 0, and then we subtract 1. We decrement the I variable for every iteration. So and then we can check the byte at the index, which is going to be s of I, and if c is less than or equal to 0x7f, then it means it's an ASCII character. And you can just continue. And then if it is a 2-byte long sequence, which is going to start with a byte in the range of C2 up to DF, then it means we are dealing with a 2-byte character, UTF-8 to, and this is going to be in the range of 0xC2 up to 0xDF, and this means we want to replace the previous character with this one. So reverse bytes, pointer to S at I-1. So this is going to be the previous character in the string, and this is going to be 2 characters long. And then we also decrement I, so that we do not end up, we do not go over the same character twice. And then you can just continue. And then if it is 3 characters long, it's going to start with a byte in the range of E0 to EF. So we can say if C is greater than 0xE0 and it is less than 0xEF, then we reverse bytes starting from the index of S of 2 bytes ago, 2 bytes to the left, which is the pointer to S at index I-2, and then the length is going to be 3, and then we decrement I by 2, so we do not step over the characters we have already reversed, and then we continue, because we do not need to go to the next branch, and then if C is greater than or equal to F0 up to F4, then it means we are dealing with a 4-byte character. So this means it's we are starting with s at index of I-3, and we are reversing it a 4-byte character, and then we decrement I by 3. And then, if we do it like this, we should get a properly reversed string. Let's see. So now, if we run this on the same sample text of the same test string, we are getting proper. Okay. Let me show you the original string and the reverse string. So we can see this is the same length as the reverse string, and it has the same characters. So these are all valid Polish diacritics. And I think Polish diacritics are 2 bytes wide. Let's try with something more complex. Let's try with Japanese. Let's say konnichiwa senpai. And this is just a sequence of hiragana. This is these are kanji, and there are some wide punctuation characters. So when you print it out to the terminal, we're getting correctly formatted Japanese text, and if we try to reverse it, we are getting correctly reversed Japanese text. So now let's try with some emoji. And I'm going to open up Emojipedia, and I'm going to pick some examples. Let's say this is fire, because I'm pretty sure this video is going to be fire. And then there is this this emoji of flushed face, I think. Oh well. Yeah, I'm going to. Yes, this is flushed face. And then let's take a pile of poo. Okay, the fire. And then a flushed face. And then pile of poo. Okay, great. So now when I print it out of the terminal, this displays correctly. And then when I try to reverse it, we are getting a correctly reversed sequence of emojis. Great. So now let's try to reverse some flags. For example, let me pick the flag of Estonia. Okay, we're getting the flag of Estonia. And now some flags. Estonia. Great. I print it out to the terminal and it is correctly reversed. Great. And now if we reverse it, great, we are getting a reversed text with a flag of Estonia. So surely this is also going to work with the flag of Iceland, right? So now if we copy this line, yep, Iceland is here. Great. So now if we print it out, we're getting the flag of Iceland. And now let's reverse it. Oh no, what happened? We are getting a flag of Slovenia. So if you know anything about how flag emoji works, these are basically ligatures. And ligature is a fancy way of saying that two characters put together will be displayed together. So like an example is in fancy fonts, you can, if you put the letters FI together, you're going to get the I above F is basically going to merge with the dot above the I is basically going to merge with the F. And something similar goes with emojis. Now you can even see it in my terminal, because this terminal isn't very happy about such wide characters. So if I refresh it using Ctrl L, this is going to be displayed as flags again. But I'm telling you, this terminal really doesn't like flags. So now, if we go deeper, you can know that the Iceland emoji is actually a flag sequence. Oh, it's called a flag sequence. And so this is basically what is going to happen. If I copy the letters B, E, like so, B, E, we're going to get Belgium. And if I copy the letters, wait, where is U? U, S, we are going to get the flag of the United States of America. So now if we try to reverse it, we are going to get bollocks. We're going to get unknown flags. And the reason this is happening is because not all characters in Unicode are going to be just one code point. And for example, some emojis are up to 13 bytes wide, I think. For example, there is this man in suit levitating. Person in suit levitating. Okay. So this emoji, technical information. Yeah, it combines 2 code points. And if we do the man in suit levitating, it contains as many as 5 code points. And if you even try to display it with a, so if your platform does not support this particular emoji sequence, you're going to get gibberish, or you're going to get display that is not entirely correct. So basically, if you want to make sure that you are really correctly reversing a Unicode string, you need to know how each sequence behaves together. And I'm going to show it to you on the example of 2 programming languages. I'm going to open up Elixir, and I'm going to basically re-implement the whole program using Elixir. So if I read the file sample.txt, okay, I'm getting it as a string, and now let's break it up into lines. So this is going to use string split, and I'm going to split by new lines. Okay, I'm getting everything with lines. And now I'm going to map over these using string reverse. And I'm going to join them using new lines, and I'm going to print it out. So unexpectedly, if we do the same thing using Elixir, when Elixir actually knows how to reverse this, that these flag sequences go together, and it does reverse them correctly. So it basically just puts this whole sequence together. And this means that the Elixir programming language has something that tells you how to deal with every character. And you just have to know that if you are dealing with complex UTF-8, it's probably better to just use a higher level language or a library. And if you enjoyed watching this video, please consider liking and subscribing. If you did not enjoy this video, please tell all your friends how bad it was and send them a link so they can just come and see it on their own. And I hope you learned something, and I will see you in the next one.